Welcome to Six Sigma Black Belt, Course 4, Module 7, Process Capability. Process capability requires a predictable pattern of statistically stable behavior. We typically characterize this with a bell-shaped behavior. We draw comparisons between causes of variation and engineering specifications. A capable process is a process whose spread on the bell-shaped curve is narrower than the tolerance range or specification limits. Process capability studies consist of three phases: planning for data collection, collecting data, and plotting and analyzing the results. The objective of process capability is to establish a state of control over the manufacturing process and then sustain that state of control moving forward. Any number of actions can be taken when comparing process limits and specification limits. First, we could choose to accept the outcome. This typically means that the process limits fall well within the specification limits. We could choose to change the specification. Sometimes specification limits may be unrealistic and set tighter than needed to add extra cushion. Remember that tighter specs translates into more cost. Make sure your expectations are aligned with your customer. Your customer will not pay for a product with more value than what they demand. This translates into lost revenue. Centering the process is a very easy thing to do. It helps to establish a mutually agreed upon starting point from which to implement further improvements. Reducing the variation will yield the best long-term benefit, but it is also the hardest to attain and maintain. Design of experiments can be used where there are many sources of variation to localize and separate sources into understandable partitions. Finally, there are many times when we just have to accept the loss. Clearly, this is a temporary solution, as scrap and rework must always be kept in check. There are many other potential applications for capability. Capability studies can provide the basis for a variables control chart. They can establish a baseline for new equipment. Capability studies can allow us to reassess tolerances based on the inherent variability of a process, as well as identify and dedicate more capable equipment to do more rigorous jobs. They can also help us assess ongoing performance of equipment, as well as assessing the effects of adjustments. The identification of characteristics to be measured in a process capability study should meet the following requirements. The characteristics should be a key factor in the quality of the product or process. It should be possible to adjust the value of the characteristic. We should also have the ability to control the operating conditions that affect the measured characteristic. Pare down your surveillance of many parameters to a short list of critical values. These measures could be based on customer contract or government regulation. Only measure the things that you know you need to assess the viability of the process. Specifications come from customer requirements, industry standards, or the organization's engineering department. Process capability studies serve to ensure that the process is properly maintained, but also to evaluate and improve the process in order to meet the tolerance requirements when it is found to not be capable. As mentioned earlier, sometimes we set specifications too high in relation to the achievable process capability. We can either open the specification or possibly 100% inspect the process. This is a last resort. Ideally, we should look for ways to ease back on the requirements. Always ask if your requirement is something the customer will pay for. If not, then we should definitely reevaluate. Sampling plans for conducting process capability studies depend upon the goals as well as the customer or regulatory requirements. If the process is currently running and is in control, control chart data may be used to calculate process capability indices. For new processes, a pilot run may be used to estimate the process capability. The disadvantage of using a pilot run is that the estimated process variability is most likely less than the process variability expected from an ongoing process. When seeking to improve the process, a design of experiments approach is desirable. Here, the optimum values of the process variables are used. This will yield the lowest process variation. For attribute charts, capability is defined as the average proportion or rate of nonconforming product. We have 4 types of attribute charts. With P charts and MP charts, the process capability is the process average nonconforming, P bar, and is preferably based on 25 or more in-control periods. With C charts, the process capability is the average number of nonconformities, C bar, in fixed sample size. For U charts, the process capability is the average number of nonconformities per unit, or U bar,